asking for this particular?
Okay, so we're going to go through the forms here in just a minute.
Okay.
We're not quite filling it. We're just talking through. Okay.
Okay.
So forms of quadratics. You have this little flip book, and it's got standard, vertex, and intercept form. Okay. Now, what I like to do is compare it to what we had previously. So we look to the back and go, what do we already know? How do I apply what I know to what I don't know? We know everything about linear equations. We went over this. We saw a standard equation as ax plus by equals c. We knew our point slope was y minus y1 equals m times x minus x1. And we knew that our slope intercept was y equals mx plus b.
Yep.
Right? 3 forms for a line. Well, what we're going to see is that we have the exact same 3 forms for a quadratic. I've tried to color code them so we can see the same thing. So where we had a standard equation for a linear, we now have the standard equation for a quadratic. All right? Looks consistent across there. Where we had a point slope for a line, we have, they call it vertex, but the vertex is actually a point on the line, right? So it's a point and the slope of it. So we called it point slope here, we call it vertex slope here,
Okay.
but our vertex is a point, so we could kind of rename it point slope form for a quadratic. We have our slope is in the same location, and then here is our point, our x and our y value, our x and our y value, okay? Where we had slope intercept form, this happens to be the y-intercept,
Okay.
right?
Yeah.
For a line, our intercept is the y-intercept, but we have the slope and an intercept, although it's the y-intercept. Here we have the intercept, it's just our intercepts are now the x-intercepts, not the y's. But we still have slope, intercept. Same values, okay? So standard, point slope, slope intercept. We're looking at the same thing. We've just taken our straight line and we've curved it. So it makes sense that all of our forms, all of our formulas still are basically the same, are valid across there, okay? So here's an example. With real numbers, this is one line and all of the ways that we could write one line. We worked a lot of this. We had homework that changed us between all the different lines. Here's our standard form. We moved it over. We put a point in there. Here is our point slope form, and here is our slope intercept form. In the same way, here is our parabola. Here's our standard form of our parabola. We could rewrite it in point slope. So we call this the vertex because now it gives us our vertex. This is the point it gives us. Or we've got slope intercept form. Okay. Same exact graph, 3 different ways to look at it. Right? So this is like your mom's name, what you call her, and what your dad calls her, right? Same thing, same person, different names, different ways to look at it. Okay? So I printed out a paper for you. We are going to just identify, you have this slide printed out right here. We're going to identify whether or not it's in the standard form, the intercept form, or in the vertex form. So standard form, let's find all of the ones that are in standard form. Standard form, we can look at it here on the little bottom, means that all of our values, it starts at x squared, it has x in c, so ax plus bx plus c, all on one side.
So,
Okay. Is there any other one that's in standard form? Will standard form have parentheses involved? No, it
So
will
yeah,
not.
that one's in standard.
Yes, that's in standard. Okay, so 1 and 6 should have been in standard, okay? So let's look at vertex. Vertex has how many parentheses involved?
So it's one set.
Just 1, right? And then it has an extra y on the outside, right? Because if we are looking At point slope, we only have a parentheses that involves our x, and then the y is extra on that outside. Right, so did you get 2, 4, and 5 with vertex?
Yes.
Excellent. Okay, so then our intercept has how many parentheses?
2 sets.
2 sets. So it kind of makes it easy just by looking at the parentheses, maybe,
Yeah.
to figure out where they're at. All right, so we should have standard vertex, intercept vertex, and vertex standard from 1 to 6. Perfect. Okay, now let's just talk through what do we know about all these guys. Number 1, what direction does it face?
Number 1 faces down because it's negative.
Where's the negative?
Oh, sorry. Faces up.
Okay. So let's talk through what is the A value of number 1?
1.
What is the B value?
Negative 2.
What is the C value?
Negative
1. Okay, so it faces up. Okay. We can find the vertex by negative B over 2A. Right, so if our B is negative 2 and we look at negative B over 2A, we worked through that last week on a lot of our problems. So negative of a negative 2 over 2. So our vertex X is 2 divided by 2, 1. So it's at 1. It's at 1 something. How do we find the Y value for the vertex? We now know the X value. How do we find the Y value?
You just make the x's 0?
We make the X what?
1.
Yeah, we're trying to find this coordinate point. Our equation tells us
What x equals?
when we've decided this is our independent value, right? We've decided that X is going to be 1. So now our dependent value is our Y. We've got to figure out when we decide that X is 1, Y equals what? So we plug in 1 to each of these. So 1 minus 2 minus 1. So 1 minus 3 gives us
Negative 2.
negative 2. So now our vertex is there. Is it a maximum or a minimum?
It'd be a minimum.
Because
Wait. Yeah.
because
It faces up.
the slope is positive. So it's a minimum. Okay? So that we know how to look at it with a standard. So let's look at number 4. Okay, what direction does it face?
Up.
Up. Okay, where is the vertex located? Do we have to use negative B over 2A now? No, it actually tells us where the vertex is located. What is
1 and 3?
Where is our vertex located? Write our empty coordinate next to it. Okay. Our vertex is located at HK. So where has the X been moved?
Negative 3.
-3, right? Okay. Where has the Y been moved?
Up 2.
2. So in the vertex form, we can immediately, when we looked at the standard form, could we immediately know one point of that graph? Just by looking at it? No. We had to figure it out with the negative B over 2A and do some math. Okay? When we look at the vertex, can we immediately know one point of that graph?
Yes.
Yes, we can always immediately know the vertex, and we can know what direction it faces. So it faces up, so that vertex is going to be what? The maximum or the minimum?
Minimum.
The minimum, so whenever we graph it, we know our graph has to go up from that point. Okay? So let's look at number 5. Okay? What point do we already know just by looking at that?
11. Positive 11.
We know it got moved up positive 11. Okay, so that's our Y value.
And it got moved over 5.
It got moved over positive 5. And so what is that point that you just found?
The vertex.
That's the vertex. Okay? So we're looking at 5, 11. We're looking at up here. Is it the maximum or the minimum?
be the maximum, wouldn't it?
Because
It faces down.
it's negative, it faces down, so everything has to go through that, like that. So it's the maximum. Excellent. So we could already kind of graph it. Okay. So then let's look at number 3. So number 3 gives us our intercepts. So when we looked at 5 and 2 and 4, we can automatically see a point on the graph. So with this one, with the standard form, we see 0 points on the graph. We have to do math to figure it out. With vertex, we already know 1 point on the graph. When we are in intercept form, we know 2 points on the graph. Okay. What points do we know? Okay. We're going to look at this. Okay. These are our zeros. I'm going to back it up. Okay? We know 2 points. Now, for these to be intercepts, we already decided it's where it intercepts which axis?
Wait. You're saying this is the x and y or this is
For a parabola, we're looking for the zeros. We're looking for the solutions. Where are the solutions found?
the x-intercept.
The x-intercepts. Correct. So it has to be where it intercepts the x-axis. And what question do we answer? Y has to be equal to 0. Okay? We are looking for the places where our coordinates are y equals 0. Alright? Because we're setting equals 0. Now, when we have an equation in our intercept form, we're going to change y equal to 0 to find our x's. And then we're just going to solve for it. Well, how many ways can we find y equal to 0? If I have y equals a times b, and I change it to 0, my rule with multiplication is that if any of the values are 0,
It's 0.
the whole thing is 0. So could I have a equals to 0 and b equal a number and still get 0?
Yes.
Yes. Could I have a equal a number and b equal 0?
Yep.
Yes. So we're looking for all of the ways that we can make this equation 0. There's 2 different ways we can make it. We can make the first part of it 0, and it makes the whole thing 0. Or we can make the second part of it 0. Do they have to both be 0 at the same time? No. Okay. So the way we do that is we say, we're going to make this first part 0. X plus 3 equals 0. How do I make that 0? What does x have to be?
-3.
X equals -3. That turns this first section 0, and it zeroes out the whole thing. Right? Now, so the second way is I can make x minus 4 equals 0. X equals +4. So there's 2 different ways that I can make this equation 0. Why does this negative not matter?
0 can't be a negative.
If I do, because this is really -1, 0 divided by -1 is still 0.
0 doesn't really have a sign.
Yeah, it doesn't have a variable. 0 doesn't have a sign. We just get rid of it. So when we have it in intercept forms, we found 2 places that y is equal to 0. So we move this over. We say the first place was at -3. The second place was at +4. So we go 1, 2, -3, 2, 3, 4, +4. These are our 2 spots where we are finding our zeros. Okay? So our standard form gives us no points right off the bat. Our vertex form gives us 1 point. Our intercept gives us both points. Now, does our intercept give us our vertex? No. But it sort of does. We'll talk about that in a minute. Okay? Lots of critical thinking here. Keep seeing it's the big web. We're going to see how it all goes together. So here was our first one. Those were our graphs of them. Had those in there. Okay. So now that we've seen the different ways, and that is on here. So when we have one equation, we can write it in 3 different ways. Let's look at this one. Okay. We write in 3 different ways. Let's look at your notes right here and see what we did. When we have our standard form, to write it in the standard way, do we change anything? No. These are exactly the same.
Yeah.
Correct? Standard form. We know what that looks like. When we have our standard form, what did they do to get the intercept form?
Greatest common multiple, right? Or
They made the vertex.
To go from standard form
Oh,
to the intercept form. What did they do? What did we do? What did you do all week?
factor. Sorry.
Factor! Okay, now do you know why I had you factor so much this last week?
Yes.
Okay, so to go from the standard form to the intercept form, all we do is factor it. Okay, now to go from the standard form to the vertex form, we've got to do a different process.
X term is squared and separate from the constant.
Mm-hmm. And that's actually a form called completing the square, and we're going to address that in a minute, okay? So as we find the solutions, as we're going to go ahead and move it, we're trying to tie all this together. As we go ahead and start addressing our solutions, knowing either what form it's in or how to change it to that form helps us know which way we're going to find our solutions. It's like, which door do we open and how are we going to, what step do we take? It's like the end of, choose your own ending mystery novels, okay?
Yeah.
So we're going to get to the end no matter what, just which door do we look at? So let's think through. If I have an equation and I can easily factor it, is that a choice you would want to make? If I can look at it and I can easily factor it, how many solutions does a factored equation, factored form give us?
Gives us 2. doesn't it?
It gives us 2 already, right? And we're always looking for the solutions. So the easiest form to use is our factored form, because it already gives us a solution. And what's the whole point of math?
Find the solution.
To find the solution, right? So the factored form gives us the solution. It's the easiest way to find our solutions. What did we notice whenever we did that? What happens when we set each one equal to 0? It's exactly the same as the h. It's the opposite value of what you see. So on the one here, what are our 2 solutions?
It would be 6 and -4.
Positive 6, negative 4.
Yep.
Positive 6, negative 4. So when we can factor it, we already get our solutions really quickly. We have 2 options. Okay? We're going to look at this guy. Okay. When I have my, actually I don't like that guy. Let's do another one that's easier. Let's see. This guy. When I'm given my solutions in factored form, I could say that this is -3, 0, correct? This guy is
4, 0.
4, 0. So can I write the equation for this quadratic?
Yep.
Yeah.
Yeah, if you put in the
I just say, right, if it's -3, 0, that means it was x
Positive.
plus 3.
Mm-hmm.
If it was 4, 0, it was x
minus 4.
minus 4, and then we can multiply that out and get x squared minus 4x plus 3x minus 12,
Yeah.
right?
Yep.
X squared minus X
Processing.
Yeah.
minus 12. So,
Yes.
because I knew my two solutions, I can go back and write the original. This is the whole doing, undoing. We're going back and forth in that. There's also, let's figure out, where would the vertex have to be? Okay, I know I have it written up here. I want you to we're going to use some critical thinking skills. Parabolas are symmetrical. Symmetrical means they are identical on one side and on the other side, correct? The place where they're folded is called the what?
The place that they're folded is axis of symmetry.
Axis of symmetry. The axis of symmetry has to go straight down the
Vertex.
vertex. So we know the axis of symmetry has to go on the vertex, specifically which value of the vertex?
The X.
The X, right here. Okay, we're taking what we know, apply to what we don't know. Big brain skills, okay? Now, the axis of symmetry also has to go down the
Y.
middle
Oh.
of the graph, right? It has to go straight down the middle, right? Well, if these 2 points are on the graph, the axis of symmetry has to go down the middle of them,
Okay.
right? So what is our distance
It'd be just half.
between those guys?
7.
7. Our distance is 7. What is the middle?
Just 0.5 or like 1/2.
What's the middle of 7? How do we find the middle of 7?
3.5.
Okay, 3.5. On that side, 3.5. So we're finding an average, right?
Okay.
So if I start at 4 and I go back 3.5, I end up at x equals 0.5, correct?
Yes.
Or 1/2?
Yeah.
Either way. If I start at -3 and I come this direction, 3.5, I end up at 0.5 or 1/2, right?
Yep.
So now, can I find my vertex? We just found out the x value has to be
1/2.
1/2. We already wrote the equation. It was x squared minus x minus 12, correct? When we worked that out?
Yes.
Okay. Now I found that x is 1/2. Can I find my y?
Yes.
Yes.
Yeah, I can find my y. It's actually 12 1/4. We have it up there. Okay. So, from our intercept form, we found the intercepts, the 2 solutions where it crossed. Because we knew the 2 solutions where it crossed, we knew the axis of symmetry because it has to be exactly in the middle of them. Because we know the axis of symmetry, we know the x value of the vertex. Because we know the x value of the vertex, we can find the y value of the vertex because we just plugged in, or we can leave it in this term, right? We could leave it in that. We could solve it like that, right?
Yeah.
And find out the y value?
Yeah.
Either way, do we have to put it out in this form? No. We've already said x equals 1/2. There's a negative there. Okay, so we find it. So we get lots of data with 2 little points. Okay, you see how all those are all connected? It's a big web.
Yeah.
Okay? Got it? Okay. So, knowing how to graph it was valuable. We needed to know how to tear apart our formulas and our equations so that we knew this is what direction I should be going, this is my slope. We can at least figure out a big picture from there, okay? Remember, we are looking for solutions. solutions are called the roots. They're also called the zeros because y is equal to 0. Okay? So, factoring, the easiest way, it gives us the two solutions. Okay? Roots is whenever we're going to take a square root. Why would we take a square root? Because our equations are all squared. So to undo a square, we have to do the roots. So that's why I call it PERMDAS. The beginning, I said everything has a thing that undoes each other. Addition and subtraction, do, undo. Multiplication and division, do, undo. Exponents and roots, do, undo. Okay? So to undo an exponent, we have to take a root. And we're going to dive deep into that next week. Okay? Completing the square is another way that we can find it. And this forces it into vertex form so that we can find 1 point, right? Or the quadratic formula. Worst case scenario, you plug it into the quadratic formula and you always get it. Now, for any equation, you can use all 4 of these and you will find the exact same answer all 4 times. And that is what our mind map and stuff shows. We've got one equation, we've solved it 4 ways. Do you have to solve it all 4 ways all the time?
No.
No. This is about taking what you have and finding the easiest one. We're going to pick, for this equation, which of these 4 is the easiest? Okay? Or which of these 4 is the one that I'm most comfortable with? Because every single person might have one of these that they're more comfortable with and want to solve. Okay?
Can I use the restroom real quick?
Yes, absolutely.
Thank you.
Okay, so with factors, we already know, we just went over why factors are important. Factors give us our 2 answers, right?
Yes.
So that's why we worked so hard on factors last week, because if we can find factors, we already have our answers for it. We know where it crosses. So in this guy, if these are our 2 factors, we are at -2, 0, 1, 2, 3, and at 3, 0, we can rewrite our factors as binomials. This guy came from x plus 2.
And then that guy came from
X minus 3. So there's our 2 binomials, and we could say our entire equation is x squared minus 3x plus 2x minus 6, x squared minus x minus 6, right? So I had 2 points and I rolled a whole equation for it.
Yeah.
And that's a lot that we can do. We also know where our axis of symmetry is. Where's our axis of symmetry on this guy?
Okay, so you have to go 5 points to meet each other.
Okay, which means halfway is how far?
2.5.
2.5. Okay, so 3 minus 2.5.
Gives us 0.5 or half.
Okay, or -2 plus 2.5.
That gives 0.5 or half.
Okay, so we're consistent.
Yep.
So we automatically know that our axis of symmetry lies on x equals 1/2 there, which means I can plug this guy in
And then solve
for those and have, right?
Yeah.
2.5 times half minus 3 -2.5, right? And we would find our y value for our vertex. Where we plug it in right here. We can plug in 1/2 squared minus 1/2 minus 6 and get 1/4 minus 1/2 minus 6. They all have to have the same denominator. So we're going to turn that guy into 2/4, turn this guy into 24/4, and have -25/4 is our y value. Which means he's down here.
Yeah.
And if he has to go there, that means my parabola faces up. And now we have 3 points, and as long as you have 3 points, you can draw any parabola. So what do we notice? When we had a linear equation, we had to have 2 points to draw it. When we have a parabola, we need 3 points to draw it.
Okay.
So quadratic, we need 3 points. With any 3 points, we can, if we've got the vertex and 2 points, we can draw the line. Okay? So that's what we walk through. It's always symmetrical. So when we know our 2 points, we can find our axis of symmetry. There, okay? So this, we work through these factoring. We're not going to do that for time. Today you guys know how to factor this. How do we read it when we factor?
Okay, so it's always going to be on the opposite side. So 88, and then
What factors of 88?
what factors of 88 plus?
Add up to
Sorry,
19.
Add up to 19. What factors of 88 add up to 19?
8 and 11.
8 and 11. Okay? So we can factor that one easily. Now, this guy, can we factor him as is?
No.
No,
We
have to
want
get rid of the negative 3.
To try to get rid of him first. Could we factor out the negative 3?
Yeah.
Yeah. All of them, a 3 can come out of?
Yeah.
So if I take the negative 3 out front, I get left with just an x there. 90 divided by negative 3 is negative 30. Now we read it backwards.
So
What factors of 30?
Add up to,
No.
Well,
or like when you subtract them, they equal -1.
Yes. What factors of 30 subtract to be 1? Right? And the biggest number gets the
Negative.
negative sign. Right? Okay. What factors of 30 subtract to be 1?
My brain is not braining.
6 and 5. So we're going to put 6 and 5 in. The biggest number gets
The negative.
the negative, and because it's subtracted, that means they have to be
Different.
Opposite.
different signs. So what are our solutions?
X equals positive 6, and then x negative 5.
Perfect. Okay. Our axis of symmetry lies where?
In between them.
Okay.
So it'd be,
Be about 11. I think.
it'd be,
So where do we find the middle? Yep, we've got 11.
it'd just be half.
It's at a half again, is our axis of symmetry. Okay? And then we would plug that in to find our vertex. Where should our vertex be? Is our vertex going to be a maximum or a minimum?
It'll be a maximum.
Because
It opens up, or
Since it goes.
it opens up down. The slope is negative.
the slope is negative. So our graph is going to go through these points that way.
That would be it.
We're going to have our vertex up at the top. Okay? So if we get a vertex point, this is when we plug it back in, if we get a negative y value, we made an error. Okay, that's how we double check ourselves. My y has to be positive because I've got to go through these and it has to go down.
Yeah.
Okay? So we're gonna skip the roots ones for right now. We're gonna go over that next week. Okay?
That's a lot of roots.
Yeah, there's a lot of roots. That's why it's all gonna be, we're gonna do that next week. Okay. Completing the square. Completing the square is when we have values and we can't factor it right away. So we have some equation that we're like, that doesn't factor well. Or we want to put it in vertex form. So to do that, we need to have just our x values squared. When we are putting it in this x minus h squared form, this is a perfect square trinomial, right? We know it's the first guy squared, 2 of the middle guys, the last guy squared when we put it in. So we can force it by making a new value. So this is what we're going to learn, okay? This can often be a really difficult concept. I'm just letting you know straight up front, okay? So we are looking at the solutions one. So we're working down this guy right here, completing the square. We're working down the center part. Right there, okay? So, x squared minus 10, plus 10x minus 3. Well, right away, we know that we can't factor this because our c value is less than our b value. And so, what factors of 3 subtract to be 10? Nothing. We can't do that, okay? So, when we know we can't factor it, we're going to force it to factor. To force it to factor, we're going to get rid of this 3 because he's the problem. Right? So, we're going to use all of our math rules. So, I want you to tap in math. We can do anything to any equation as long as we do the same thing to both sides. Right? Right? Got this? Okay, this is where we're going with this. So, I want to get rid of the 3, so I'm just going to move him over. And I'm going to leave a space. Okay? You clear with me on that one?
Yes.
Now, I want to turn this guy into this form. Right? I want it to be an x plus or minus a variable, a constant, that when I FOIL it out, I get x squared plus 10x plus something. Okay? So let's think through. When I have this, I want it in this form. Okay? When we FOIL, we get x squared. Our outer and inners is 3x. Our inners and outers is 3x. And we have 3 squared on the end. So we have our first guy squared. We have 2 of these guys. Right? And then we have our last guy squared. So that means when I do 6x, x squared plus 6s plus 9, 6x was 2 of the exact same things added up. So that means 10x is 2 of the exact same things added up. So what 2 things does it have to be? 5x and 5x, right? 2 of the exact same things added up got me to 10. Okay. So I went from 6 and I said 2 of the same. Where does this end number come from? It is the coefficient of that 2 squared, right? Because this was the 3.
Yes.
Right? So I can already rewrite this and go, oh, this has to be x plus 5. When I divided it up, it has to be that 5. So now I've already written it in my binomial. But I want to figure out what guy goes right here. So if I have x plus 5 squared, what's my end term?
25?
5 squared. Yes, it's 25. So to force it into x plus 5 squared, I decided it had to be 5 because 5 is half of 10. Now I have to square this value to get my 25 there. So I added 25 to this side. But my math rules say, whatever I do to one side, I have to do the other side. So if I add 25 on the left, I have to add 25 on the right. So now I can rewrite my left side as x squared, x plus 5 squared, correct? These are the same things rewritten. And on the right, I have 28. Now, we want to set it equal to 0. So what do we need to do with this 28? We got to move it over, right? So we're going to leave our x plus 5 squared. We're going to subtract 28 and get 0, which is also equal to y. Right? That equals our y value. Now we have it in vertex form. Where is my vertex located?
5 and, or negative 5 and negative 28.
There's my vertex.
Okay.
Okay, what direction does it go?
Up. Or
And it goes
faces
up. Okay, so how many solutions will this guy have?
2.
2, because it has to cross the x-axis twice. All right. So here's where we work through it. Okay. Now, we solved for the vertex. We moved this over and we said x plus 5 squared minus 28 equals y. We knew our vertex is located at negative 528. Okay. Now that this is squared in this format, we can also use our roots, which we'll address this again next week, to find our actual solutions. So we found our vertex. Now we want to find the points where it crosses, our solutions. Okay. So when it's squared, we just take the square root of both sides. We'll address this more, but that's what this part is. We take the square root of both sides. We learned when we take the square root, it's always a plus or minus. When we take the square root, and we can find our actual solutions, which they are radical solutions, which we knew they had to be radical solutions because it didn't factor in the first place. If it doesn't factor, they're not going to be nice, simple solutions. Okay? So in this guy, let's look at it. 3x minus 6x plus 12. The first thing we want to do is try to get rid of our leading coefficient. So we're going to divide the whole thing by 3. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. 12 divided by 3 is 4. So here's our new equation. Okay. The reason I got rid of this 3 in the first place is 0 divided by 3 is 0. So he doesn't change anything. He doesn't make a solution. Okay. So now we're going to ask ourselves, what factors of 4 add up to be 2?
So
Are there any?
What fact? I mean, 2 and 2.
well,
Wait.
2 plus 2 equals 2?
Oh, wait.
Yeah. What factors of 4 add up to be 2?
None.
There aren't any, so we cannot factor this. So step 1 is we're going to get rid of the constant who's the problem by moving him over, and we're going to leave space for a new constant. So when we move the 4 over, that makes him negative, which I totally missed on that guy. Okay? So now we have a new space. What do we put here? Okay. So this 2 comes from what? 2 exact things that add together.
So,
one.
negative 1 and negative 1.
Negative 1 and negative 1. 2 exact things that add together. Okay. That means I'm looking at negative 1, right? He has to go there. Now, so where did he come from? So now I take this value and we're going to square it. Negative 1 squared is
1.
positive 1. Right? So, but if I put a positive 1 on the left side, I have to
Do it on the right.
put a positive 1 on the right side. Okay? So now on the left side, I have x minus 1 squared, because this is my new guy, and I'm able to factor him as a perfect square trinomial. And on the right side, I have negative 4 plus 1 gives me negative 3. So my equation, when I move it over, is x minus 1 squared plus 3 equals y. Where is my vertex located?
Negative
Well,
1.
no, just 1.
Sorry, just 1 and then positive
1, 3. Okay, is where my vertex is located. Okay, what direction does it go?
It opens up.
It opens up. How many solutions do we have?
0?
0. 0 solutions for this guy. Right? So we found our vertex, but we won't have any solution answers for here. They're going to be imaginary.
2.
All right. So this is what we see when we complete the square. It forces it into our vertex form. Right? So factoring forces it into our intercept form. Completing the square forces it into our vertex form. It depends on what we're looking for. We're so close. Okay. Now, we can always use the quadratic formula. All the time. It will always work. Okay? It's just a lot of data and making sure you plug it in accurately.
This was Mrs. Cromwell's favorite thing to use.
Okay, so the quadratic formula, we always need to make sure that we identify them with our A, B, and C value. It's identified on your notes there. Once we have our values identified, we're just plugging them in. Negative b plus or minus square root of b squared minus 4ac over 2a. Okay, now the important thing is that we recognize that these b's are technically inside parentheses. So if our b value is negative, we might have negative of a negative 2. Okay, anytime we square a negative, this will always end up being positive. So this first value should always be positive, because it doesn't matter if it started out positive or negative. Okay? So my suggestion when you are plugging in your values is that you use lots of parentheses, and that your A value, your B value, and your C value are all lie within a parentheses, so we keep that sign with it. Okay? Now what's interesting is that when we look at our quadratic formula, we get to see a lot of data that we've already seen. Negative b over 2a, that was how we found the vertex, right? As we'll look at next week, our plus and minus is all of our solving for our roots. And then we're going to explore the discriminant, which that actually tells us, does it have 1 solution, 0 solutions, or 2 solutions, okay? So lots of different ways that we can solve it. We will explore discriminants, roots, and imaginary numbers next week to add on to what we already know. Okay? So take your notes, make sure that you have put your vocabulary into your interactive notebook, that you put your quadratics into it. What I would like you to try to do is to fill out the rest of your little booklet according to what we know. Like here, the axis of symmetry is x equals h. We're using our h and k values, okay? So the vertex is called h and k all the time because we're looking at this vertex formula here at the top. Our vertex is located at hk, so the axis of symmetry is x equals h, right? It's equal to our x value. Okay, so on the one on the bottom, they have given you an equation. We're just going to plug in. So A equals 2.
Yep.
H equals
Negative 4.
Well, it'll be, we have to multiply it by the
4. H equals positive 4.
Yeah.
Okay, the H and K are not affected by that A value. Remember that A value just tells us the slope.
Yes.
And then K is equal to
Negative 3.
-3. So the vertex is located at 4, -3. I'm just plugging in what we know. All right? And then I will send this out. So this is part of your homework, getting these guys filled in.
What is, we don't
Right.
remember this guy.
Because we're gonna be tying them all together. This is how linear and quadratics and exponents work together. So I want you to attach them into your interactive notebook. Linear equations. We already know slope. We know y-intercepts. The 0 is where it crosses. You should be able to fill all of this in based on what we already know about lines. Okay? Same thing for quadratics. They are giving you the equation, so we should be able to fill in all of this data based on here. And then when we get to exponents, we will fill that in. But this is another part of our homework, is filling out our guides. Okay? And then I am going to be sorting through all of the homework and figure out what I'm gonna assign. And it might look like a choice board, so that you will be determining which
Like what you prefer.
which ones you want
Okay.
for it. Okay? And this is somebody's, is that yours?
It's probably mine.
Okay. All right.
Where's your marker back?
Good job, guys.
Thank you.